Hi, this is Sarah Zamfari, and in this video, I'm going to talk about question number 1 of homework 4, probability and stochastic processes course. Okay, in the first question, we want to calculate and draw the probability density and the probability distribution functions of random variable y in terms of random variable x. When we look at the formula for g of x, we understand that only in range of 1 and 2, the derivative is not equal to 0. Because of the formula that we have for probability density function of y, which is equal to probability density function of x, divided by the derivative of g of x, we know that the f of x is defined in the range that the derivative is not 0. So we will focus on this part. Now let's go to my answer to this question. As you can see, I have written the probability distribution function first, which is equal to the probability of random variable y being smaller than y, which here we can substitute y with minus x plus 1, which is the value of g of x in the range of 1 and 2. Okay. After doing some calculations, we get to the probability of x larger than minus y plus 1, which is equal to 1 minus probability distribution function of x in minus y plus 1. Okay, this formula that I calculated here is for the range of x between 1 and 2, and for the range of y being from minus 1 till 0. So I can write down the formula like this, and we know that because this is a probability density function, this is a probability distribution function, y greater than 0, we have the value of 1, and otherwise the value is 0. Okay, now we have the formula for probability distribution function. And we can write the closed form, which is so simple. We can write it using the step function. For the range of minus 1 till 0, we use two step functions. One step function minus the other, so that we can make the range. And for the one, which is the value for y greater than 0, we can just use a step function u of y. Okay, now we get the derivative of this, and we will get to the probability density function really easily. Okay, now let's plot this. Let's draw this. For drawing, at first, we draw the probability density function of x. And in the range, and we select the part which is in the range of 1 and 2. And this part is going to be for the probability density function of y in the range of minus 1 and 0. And we have two impulses in the point minus 1 and 0, which we can calculate easily from a formula that we have here. And let's go to the probability distribution function. We have the probability distribution function of x, and we just draw the 1 minus probability distribution function of x, because in the formula we have 1 minus the f of x. So we draw this as our first, as our diagram, and we use this to have the f of the probability distribution function of y. And we see this again, we choose the part which is between minus 1, between 1 and 2, and we use it for minus 1 and 0, which is this part. And we know that for y being smaller than minus 1, we have 0, and for y being greater than 0, it is 1 because this is a probability distribution function. Thanks for listening to this question. Thank you.